All right, so this is like homework 7.1. If we have squares going on and it's just sines or just cosines, then we can do a substitution. So here we could say, let's let x, use capital X, equal the cosine of theta. So replacing the cosine of theta with the x, we're going to get 8 capital X squared equals 3 minus 2 capital X. And so now it's like a problem from pre-calc 1. And when we have squares with a variable like this, we usually get everything on one side and 0 on the other. So we are going to subtract the 3 over, we're going to add the 2x over, and none of these are like terms, so the best we can do is list them out in order. So then we're going to get 8x squared plus 2x minus 3 equals 0. And we can either try and factor or we can use the quadratic formula. And if you don't like factoring, just use the quadratic formula. So yesterday I did factoring, today I'll use the quadratic formula. Reminder, x equals
negative b.
Yeah, negative b.
Plus or minus.
Yeah.
All in the square root.
Yeah.
Of a squared.
B squared.
Or b squared.
Yeah.
Minus a squared.
Almost 4ac.
Dang it! I need to start practicing. Do it.
2a.
That's where.
Yeah, there's
That's where my a is.
All right, so then usually when I do that, I write down for myself things like, so I get them straight. A is 8 here, B is 2, and C is negative 3. So we're going to have B is 2, so negative 2 plus or minus 2 squared I can do in my head. Since the C is negative, I'm going to just switch to a plus here, because a negative times a positive, negative times a negative. And then I'm going to have 4 times A is 8. And now I'm just going to multiply by 3 because I dealt with the negative. All over 2 times 8. And if it factored, this will clean up nice. So let's see, will it clean up nice? That's going to be, let's see, 4 times 8 is 32, times 3 is 96, plus 4 is 100. That's nice. Square root of 100 is 10. So I'm going to get negative 2 plus or minus 10 over 16. So that will be negative 2 plus 10 would be 8/16. Negative 2 minus 10 would be negative 12/16. And those both reduce. So I can divide this one by 2 and this one by 4. So now I have what? Oh, more.
Yeah, you can
8
do more. Or yeah, you can do
here.
it.
Pay attention there. So that's going to be 1/2. And then the other will be negative 3/4. So those are what my capital X equals. Now I know capital X, I can then go back and reverse substitute with the cosine. So I have 2 possibilities here. I have the cosine of theta is 1/2, or I have the cosine of theta is negative 3/4. And I want to double check, where are they looking for solutions? Is it all possible solutions, or is it just
On the
solutions?
interval of 0 to 2 pi.
0 to 2 pi. Okay, so theta is an interval, 0 to 2 pi. Good. So then I just have to look at the unit circle and see where these lead me.
Special angle.
So yeah, the first one looks like it's going to be a special angle. So cosine of the unit circle is an x value, so x equals 1/2 is going to lead to this point here, or this point here. And special angle for this first one is going to be pi over 3 to get there. And then the other angle down here, since I have to go from 0 to 2 pi, I have to sweep around in a positive direction to get there. The reference angle is still pi over 3, so that means my other angle is 2 pi minus pi over 3. And that's going to give me, what, 1, 2, 3, 4, 5 pi over 3. All right, so I have two solutions based on the cosine. The theta is 1/2. To double check those, it's not a bad idea to whip out the calculator and ask the calculator what is the arc cosine of 1/2, and then compare that to the decimal version of pi over 3 and make sure you get it right.
So I did some of them like that.
Yeah.
So I did some of them where I went and got the decimal, because it did ask for the arc sign, and then I was like, do I need to do that for?
Yeah, so if it comes out to, if you recognize it as a special angle, you don't have to,
Okay.
but I like to do this just to make sure is my brain really recognizing the right special angle.
Okay.
And that's one way I could check to make sure my brain's doing the right thing. For the other one, the negative 3/4, I don't recollect from any of our special angle work. X value of negative 3/4 would be somewhere over here. So I have that point and that point. For x is negative 3/4. And so up here, I want that angle. So I'm going to call that, let's say alpha. Or we can keep calling it just a different version of theta. And it's going to be the arc cosine of negative 3/4. And that's not a nice number. It's just the arc cosine of negative 3/4. Make sure you're in radian mode when you calculate that. The other version of that point from the x value, and again, we have to measure it because they're going from 0 to 2 pi, we have to do the positive version of that angle. It's related to the negative of our arc cosine. So this other angle is going to be 2 pi minus the arc cosine of negative 3/4. So here's my third and then my fourth solution here. Next thing I should do is whip up my calculator and say, do those match the points of intersection on the graph? So to do that, I'm going to graph what's on each side here, where I'm going to call one of these f of x and the other one's going to be my g of x. So I'm going to whip out my calculator, double check I'm on the right track. All right, so my f of x to check is my left side. My version is 8 cosine squared. And then I'm going to do g of x. Mine was 3 minus 2 cosine. And so I think I found pi over 3. There's one of them. That decimal, I'm thinking, must be the arc cosine of negative 3/4. Let's check. Arc cosine, or you could use the cosine inverse button. Negative 3/4. Parentheses. 2.4188. 2.4188. That looks good. This one over here, that's probably the 2 pi minus that arc cosine. So let's double check that. If I give this a name like a equals, then I can just type 2 pi minus a. 3.86-ish. Looking good. And then this one, I'm probably going to get, Desmos is programmed to recognize special angle situations. And so there's my 5 pi over 3. So my 4 solutions match what the graphical version is. I think the other day when we did this, we factored. And again, sometimes quadratic formula is a great tool. It'll let you know if it factored. Either way is fine. The
If I
question,
can remember it correctly.
yeah, and again, I have to look things like at that up once in a while, and that's fine.